Good day, everybody. How are you all doing? Hope you're doing great today. Do you think that if we increase the sample size of a simple random sample from a small number to a large number, will that affect the chances of cyber attack in British firms? So, increasing the sample size, does it affect the chances of cyber attack in British firms which have experienced cyber attacks in the past year? So that is the question we are going to answer today, and I'm going to take simple steps to do that. And I might as well say that yes, there will be definitely an effect of increase in sample size in the chances of cyber attack in a simple random sample of British firms. Let's take a look. So we might reduce this a little bit. Okay, let me move this up a little bit. Does sample size play a role in affecting the chances of a cyber attack in British firms? Okay, chances, not changes. It should be chances. So let me correct that. It's chances, not changes, chances. So, a study finds that 55% of British firms experienced cyber attacks in the past year. Part A, if we select a simple random sample of 100 British firms, what are the chances that more than 60% of them have suffered cyber attacks? Okay. So, we are taking samples of size 100 in the first case, and we know the population proportion of success here means British firms, percentage of British firms that are affected by cyber attacks in the past year. So P is the uh, let me start here. P is the population proportion of cyber firms, population proportion of British firms that suffered cyber attack. Cyber attack. Okay. So P is given as 0.55. 55% in decimal is 0.55. Now we also uh, know from sampling from central limit theorem, the mean of the sampling distribution of sample proportions, distribution of sample proportions of sample proportions. Sample proportions is given by p hat is mu p hat. Oops, let me that again is central limit theorem. And the mean of the sampling is mu p hat, and that is equal to population proportion, and that in our case is 0.55. Okay, if I move this a little bit up, create some space. So the standard deviation, the standard deviation of the sampling distribution is sigma p hat. This is sigma. Read as sigma p hat. Okay. Is sigma p hat from central limit theorem. If I write it right here, sigma p hat is equal to square root of p times 1 minus p over n. So my p is 0.55 and my n, the sample size, is 100. Okay, so I need to calculate the sigma p hat, which is the standard deviation or the average spread around the mean for the sampling distribution of p hat. So how will I calculate that? I will use my TI-84 calculator. So I will do it like this: sigma p hat equal to s- second second button on the calculator on the top left. Then I will press the x square button. First column halfway down, I'm using TI-84 and I will get the square root this way. And inside the square root for p, I will type 0.55, then left parenthesis 1 minus 0.55 as the formula states. Then the horizontal line is divided by 100 sample size, everything under the parenthesis, and then I will hit the enter key only once. Okay, so that's exactly what I will do. I'll press the second button on the top left, then x square button halfway through in the first column. Second and x square gives me the square root. Inside the square root 0.55. Then I'll put the left parenthesis for 1 minus p, left parenthesis 1 minus 0.55, right parenthesis divided by my sample size is 100. And the answer is, let me see, second x square 0.55, left parenthesis 1 minus 0.55, right parenthesis divided by 100. And the answer is 0.0497. So let me write it over here. Sigma p hat is 0.0. How many places should I go? Probably four places is good. 0.497. Now, let me quickly draw a sampling distribution of p hat, a curve. Okay, so you'll see the picture. So this is, I'll draw the horizontal axis. So this is where I'm plotting the sample proportions. Remember, these are sample proportions, p hat. Sample proportion, read as p hat. And it's a bell-shaped curve. Bell-shaped curve, normal distribution like this. The center where the peak is the highest over here. This is mu p hat. And we know this is equal to p equal to 0.55. Okay. And sigma p hat we calculated is 0.0497. Now, the question asks what is the probability or what is the chance that more than 60% of British firms will get affected by cyber attacks? So, if I move this a little bit up, so the center is 0.55 over here. Center is 0.55 over here. So, this is 0.6 and we want more than zero point 0.6. So we want the area to the right of this. So we want to find out what is the probability that p hat is greater or equal to 0.6, more than 60%. And so we are going to use our calculator again. We will use the second key, then press the verse key in the third row, then scroll down to number 2, which is normal CDF. Okay. So the first thing it asks me is is lower. I'm starting my calculation over point lower from point 0.6. I have done a similar problem last time, and you can take a look. That was dealing with sampling distribution of sample means. Here it is sampling distribution of sample proportions. I want to find what is the area under the sampling distribution to the right of point 0.6. So I start my calculation from point 0.6. My upper is a very large number on the right. As you know, these curves stretch to infinity on the right. In our calculator, we signify infinity by 1 followed by 99 zeros. Hence, we press the number 1, then E. E stands for exponent or 10 to the power of. To get E, you have to press the second button and then the comma button. So first in the upper, I type 1. Then I press the second button on the top left, then comma button on top of 7 and gives me the small cap E, that is exponent 10 to the power of 99. This means 1 followed by 99 zeros, followed by 99 zeros. This is a very large number on the right over here, all the way stretching to infinity. 1E99. Okay. So, and then it asks for mu. Well, we know mu is p is equal to 0.55, and then it asks for standard deviation. We type sigma is 0.0497, and then we go down on pest and hit enter twice. Remember, on pest you have to hit enter twice. Okay, so second, then verse button on the third row. Then number 2, which gives me the normal CDF. My lower, I'm starting my calculations from point 0.6. My upper is 1E99. My mean is 0.55, population proportion. My standard deviation is 0.0497. And I go down on pest and hit enter and enter. And we get the answer. The probability p hat is greater equal to 0.6 is 0.157. 2, you might say. Let me erase that and put it here. 1.57, or leave it at third place. So that means there is a 15.7% chance. I multiplied by 100, shift the decimal 2 places to the right, that more than 60% of British firms get will experience cyber attack. Cyber attack. Now let's quickly take a look at part B. So let me press this. So part B, the question is whether the sample size will affect the chances of cyber attack. And I said yes. And I have not yet answered that question. So I have to do part B, because in part B, I've increased the sample size from 100 to 200. How will that affect our calculation? For one thing, it will change the standard deviation of the sampling distribution. So let's go over here and change the color of the ink to something more interesting. Okay, so part B. Sample size is now 200. The mean of the sampling distribution, mu p hat, is mean of sampling distribution. Still stays the same. This is the center on the horizontal axis where the peak is the highest. Mu p hat is equal to p, and that still stands at 0.55. Now let's take a look at the standard deviation of the sampling distribution. Sigma p hat is standard deviation, sometimes called standard error, same as deviation of sampling distribution of sampling distribution. And sigma p hat, as you know, the formula is square root of p times 1 minus p. Whole thing is, let me use this, divided by n. So in our calculator, I will do as I did before, second button, then x square button, y second and x square gives me the square root. Inside the square root, p is still 0.55, parenthesis 1 minus 0.55 divided by sample size of 200. Okay, instead of 100. Let's see how that affects the standard error or the standard deviation of the sampling distribution. So the calculation is second button, then x square button halfway on the first column on the left gives me the square root. Inside the square root, 0.55 times 1 minus 0.55 inside the parenthesis, divided by, that's where we have to be careful, that's where people will make mistake. We have now increased the sample size from 100 to 200, so we are going to divide by 200, and the answer is 0.035. This answer, this whole thing is inside the square root, is 0.0235, 352 you might say. Okay, now let's repeat the calculation for the probability or the chances that the proportion of cyber attack is greater than 60%. So if I move this a little bit up, and I will maybe change the color to make it a little bit interesting. So now I want to calculate what is the probability that p hat is greater than 0.6. As I mentioned before, it's area to the right of 0.6 under the sampling distribution. Sampling distribution curve. Distribution curve. So same process. So we go second button, then verse button in the third row. Second is in the top left and verse in the third row. Then number 2, which gives me the normal CDF. I just want to quickly mention normal CDF means normal cumulative distribution function. That is the area. We use this function to find area under the normal curve. So my lower, same as before, lower is still 0.6, upper is also same as before. So we do not need to change that. 1E99, very large on the right. And then let me erase this. And maybe I should move this a little bit up. Okay. Upper, and the mean is still the same. After it is the mean. It is still 0.55. The sigma is now going to change. We have to type the correct sigma now, which is, if I move this a little bit down, you will see is 0.035. So we have to change the mean, the standard deviation, the sigma, 0.035. The rest of the argument, the rest of the values are the same as part A. Only thing that is changing is the standard deviation. Want to make sure that I've got the correct standard deviation, 035. Yeah. And if you want, let me erase this 0352 if you want to do. So it is 0.0. Five two. And then we go down on pest, put the cursor or the black rectangle on top of pest and hit enter twice. Enter twice. Okay, so let's do it. Second verse, as I said, second verse in the third row. Then number two is normal CDF. Everything remains the same except the standard deviation, which is now 0.0352. And we hit go down, put the cursor on paste, enter twice, and the answer is probability p hat greater than 0.6 now is 0.077, or there is a 7.7% chance that more than 60% of British firms will experience cyber attack. I'm sorry, British firms will experience cyber attack. So I want you to focus on the probability numbers now. When we increase the sample size, the probability is only 7.7% that more than 60% of British firms will get affected by cyber attacks, okay, or will experience cyber attack. However, when the sample size was 100, more than 15.7% chance that more than 60% will get affected. So what is the bottom line? As I told in the beginning, yes, the chances of cyber attack will be affected if we change the sample size. Here we have increased the sample size from 100 to 200, and the probability or the chances of cyber attack has gone down from 15.7 to 7.7, almost half the effect, half the chance. Now, by increasing or by doubling the sample size from 100 to 200, you've reduced the probability or the chance of cyber attack in British firms. Okay, so let me quickly walk with you what I did. First was the information given to us. 55% of British firms in the past year had experienced cyber attack. So the population proportion of cyber attack is 0.55. From central limit theorem in the sampling distribution, which is the probability distribution of sample proportion, as I've shown in the diagram, the center where the peak is the highest is 0.55 mu p hat at the center, and the standard deviation using the formula with the sample size of 100 is 0.0497. So we find the area to the right of zero point 0.6 under the sampling distribution, and that area is 0.157. 15.7% that more chance that more than 60% will face cyber attack. Increase the sample size from 100 to 200, reduces the standard deviation. Reduces the standard deviation means reduces the spread. It becomes thinner and taller at the center. More probability or more chances are concentrated now at the center. Why? Because the standard deviation is decreased. And therefore, the probability or chance of more than 60% of British firms facing cyber attack has also decreased almost half from 15.7 to 7.7%. I stop here today. I'm sure you may have some questions. No problem. You can always shoot me a question in the comments area. I'll get back to you as soon as possible. If you like this video, please give me thumbs up and let me know where you are watching from. Give me a thumbs up wherever you are watching from. Let me know where you are watching from. What is the time there? It's interesting to see where people are watching my videos from. And please subscribe to my channel by hitting the red subscribe button at the bottom right corner. And also click on the bell button, which will notify you every time I upload a new video. And please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. Have a great day. I will see you tomorrow.